Stand by. 3, 2.
So in this lecture, I would like to introduce you to one of the tools that we use in scientific computing and in software development in general. The tool that I would like to talk about is something that we call version control. Version control is a way how we can make sure that when we make changes to pieces of software, that we can communicate that to others who build on the same software, or that we can also store the history of a project. So the tool that I would like to talk about in this class is called Subversion, which is one of the two big tools, the two big version control systems today. The other one being Git, and I'm going to come back to Git in a later lecture. So let me introduce to you version control in general. So the rationale for version control essentially goes like this. They've been around for a very long time, for, well, at the very least 30 years. Maybe 35, maybe 40. So the idea is this, that if you make changes in your software, it is a very useful tool to have a history of these changes, so that, for example, you can go back in time and ask, why was a particular line of code introduced? What was the rationale for this? Maybe because you think there's a bug in it and you would like to understand who introduced it and why. So you would like to have a history where you don't, it's so that you can not just look at the very latest version of a file, but at previous versions of the file as well. You want to, like I said, you want to keep that record because you want to understand why changes were made, but you also want to keep that record because you might want to undo changes. So maybe sometimes you make a modification to your program, and a week later you realize, oh, that did not work out so well. There was a bug in there, and maybe that whole approach didn't work. So if you don't keep the history of a file, then there is nothing you can do. You have to try to remember what you did and undo it. But if you do keep the history, you can pinpoint and you can say, okay, so among the 20 changes that have happened since, this one here is the one that introduced the bug, and I'm just going to undo it. Right? So you would like to see the differences between the version that was there the day before and the day when you made that change, for example. So it allows you to go back to a defined state in time and look at the version as it was at the time, for example, because you would want to understand what was it that was changed from one state to the next. It also serves as a sort of backup that helps you, obviously, if you ever make changes that break something, or if you accidentally delete a file. If you have it under version control, you can always get back the latest version that was okay, that was not corrupted, that did not contain the bug, or that was not deleted. These were the original pieces of that motivated the development of version control systems. Let's say in the very old time, something like SCCS or RCS. Later, people realized that version control systems are incredibly useful to facilitate collaboration. So today, version control systems don't just live on your own computer, but they live on web servers, for example, or central repositories, where many people can participate in the development of the same piece of software. And part of then the rationale of version control systems today is that it allows us to track authorship of software, of pieces of code, of functions, of lines. So for example, in deal.II, if I find that there is a bug in a particular line of code, I can pull up the history, who changed that line at last, for example, and then if I realize, aha, that was me, then I will have to go fix the bug. But if it was somebody else, I can send that person an email, so I can identify who broke it. Similarly, in a more positive note, of course, I can also credit people with what they have done. So let's say if you contribute to deal.II, and it comes time for you to apply for a job or to apply for tenure, then you can go back into the history of this project and you can say, I contributed 50,000 lines of code to this project, and it's certifiable. We can verify that it is true, what your claim is. So today, there are essentially two version control systems around. They're called Subversion and Git. There are many more, of course. There's many more open source systems. There are also many more closed source commercial systems, but by and large, there are really only two that are left, and I might suggest that in a few years only one is left. So Subversion and Git are the only ones that are widely used today, and I think Git is winning the race. I personally have used Subversion for a long time, and so I'm going to show you how Subversion works, because that's the one that I'm more familiar with, but I'm going to have another lecture on Git. If you ask people on both sides of this divide of Subversion versus Git, they will say that these are radically different systems. I think that has a lot to do with, let's say, the mindset of people, the ideology, the fundamental approach. But technically, Subversion and Git are not actually all that different. I want to venture to guess that you could implement both of these on top of the other if you wanted to. So I think a lot of the design of these programs is shared. So if you understand how Subversion works, I think you have already understood 3/4 of what Git really does, for example. But let me start with Subversion, because I think that the mental model of Subversion is easier to understand, even though it is more limited. Git obviously has advantages that over Subversion. It can do certain things that Subversion cannot do, but if you understand what Subversion does, it is going to be easier to understand how Git works. So let me talk about Subversion as an example. So Subversion, essentially you can visualize this in the following way. There is a central location. So let's just say there is a machine somewhere, or maybe a directory on your own computer, that stores all of the files of your project. Anyone with permission can get a copy of these files. So let's say in the case of deal.II, there is a machine that is called svn.deal2.org that serves as the central location, and if I want to get a copy of the current development sources of deal.II, I will ask that machine, and it will say, yes, you do have permission, because it's readable for everybody, and it will produce a copy of the latest versions of all of the development sources in my own home directory on my local drive. Then I can modify and edit these files, and when I'm done with the edits, then I can upload my version to the central location. Until that happens, of course, the central location does not know anything about my changes. It will just remain at what it is. Okay? But once I upload my version to the central location, everybody else can see my changes as well. So that's sort of the, that would be a model that is not dissimilar to just a general file server. The difference of version control systems is that they will store both the old and the new version, right? So, and all other versions of that project as well. So they store the entire history. I say that you can visualize this just as a directory on some file server, or a directory on your local hard drive, and that the files that belong to your project are going to be stored in this directory. In reality, version control systems store this data in a completely different format. They store it in a database instead of just individual files. They also don't store all of the old versions. They really just store the newest version, and then they store the differences between the newest version and the previous one, and the previous one to the next previous one, and so on and so forth, because the differences typically are much smaller than the actual files. So you're never going to store the real files. But that is something that we don't have to worry about. That's something that is internal to the version control system. How SVN, Subversion, or Git store the data is none of our concern. All we need to worry about is, well, there is a central location, there is my local hard drive, and I get a copy of the central location onto my hard drive. I can edit it, and then I can upload my version to the central location. So there's a certain amount of terminology that goes along with this, namely the central location in Subversion notation is called the repository. So when I say I check out a copy from the repository, what I mean is I get something from the central location. To get a copy from the central location is called checking something out, checking the project out. And when it is on my local hard drive, I call it the working copy. So the working copy is my own copy that I can work with. When I upload my modifications to the central repository, I call this to commit something. So to commit means to take my changes and to put it into the central location. All right. When you have this, like I said, the repository contains all versions of your project, the entire history. Now, in the case of Subversion, it identifies all of these old versions by numbers that are consecutively numbered. So the very first version is called 1, then I get a copy, I make changes, I check it in, I commit it, then that would get version number 2. Maybe somebody else does the same, checks out a copy, makes modifications, commits it, that gets version number 3. If I have made another modification, I'm still at version 2. I can update, for example, get myself version 3, make modifications, will become version 4. Every one of these commits has an author, a date, and a message, a commit message, so that I can identify who did it, when did they do it, and the message typically is used to identify why they did it. So you would say modify file xyz.cc so that the so-and-so function does no longer produce the wrong answer, or something that identifies why you did it. These messages are incredibly helpful. If you have committers in your project that just say change X or fix a bug in their commit messages, it does not help you at all to understand why they made that change. It's very important that you have messages that are descriptive, because you will want to go back in history at one point or other to understand why changes were made. So that may seem academic or contrived to you, but let me assure you that I do this certainly once a day for the deal.II project, that I go back in history trying to find out why some change was made. If you have a large project that has been running for a long time, you do want to go back in history fairly frequently, and it is important that you have good messages that explain why changes were made. With this repository, I can search for commits. That means I can show the history of a file or of a directory, and it's going to show me the author's date and message. I can also check out a particular version to a working copy. So even if the current version of deal.II is at revision 33,000 or so, I can still check out any particular version that I care about. And I can update a working copy to a particular version. So typically what we do is, let's say I check out a version today. Tomorrow I will want to commit something, but I want to make sure that it works with what everybody else has done. So I checked out version 33,000, but in the meantime all my colleagues around the world have already committed 20 more versions. So before I commit something, I want to make sure that it works with the latest version. So I update the local version to 33,020, test everything again, and then I can commit it as 33,021. The current latest version of the repository in Subversion notation is called the head. And it's typically written in capital letters for reasons that have probably been lost to history. So the head is the current latest version of a repository. Okay. So, like I said, in order to work collaboratively, I would check out, edit, check in. I can look at the history. I can look at who changed what. And sometimes there are going to be conflicts. And what I would like to do is I would like to just show you how this all works in practice. So I've set up on my local hard drive here I had a directory for this. I have set up a I had set up a repository on my local hard drive so that I can use this without having internet connectivity. So this repository lives in a directory, or in a URL file on my home drive, home Bangerth mass 676, in a directory that I have called .svn archive, and so on and so forth. So what I'm going to do is I'm going to go into a directory svn examples, which right now is empty. And what I will do is I will say svn check out, and then I will just enter this address, which in real projects it would not be file : // but it would be HTTP, for example. So what it did is it checked out a project directory, okay, and this project directory contains a file, firstprogram.cc. So let me go into this and take a look. So it contains this file called firstprogram.cc. I'm going to edit this. I should also say, so it said it checked out revision 8. So there have already been 8 commits to this repository. This is when I tried this out before. So no, write firstprogram.cc. Okay, so this is the program here. Let me make this a little bit larger. Essentially, it is just a hello world program. So I have main, I call a function called output, output calls hello world. So I could run this. I find this not very satisfying. This is not enough. I will just add something more. So there is so much to see here. Okay, so I've made a change. I save it. I go out of the editor. I will make sure that I can actually compile it. Yes, it compiles. In fact, I can also run it. Okay, it produces the correct output. So if I say svn status now, then it will tell me that there is a program a.out. That's what the compiler produced. That is unknown, so that's the question mark. And there's my first program.cc that is marked as m. Okay, so m means it has been modified. I can look at the differences of this. So let me clear the screen. So I say svn diff. Okay, that's going to show me the differences between the old and the new version. The old one was revision number 8. Okay, that's the one that it got out of the repository. The new version is my working copy. That's the version that I have locally. So right now, the repository knows nothing about my modification, right? It only lives in my working copy. And what you can see when I say svn diff is that it added this one line here to it. Okay. So how do I make this into the repositories? I need to commit it. So I say svn commit, and the commit message, as I said, should be explanatory. So add some more descriptive output to the program. Firstprogram.cc, and I'm going to commit it, and it shows that it committed it as revision 9. So let me take a look at this, at the history of this now. So if I can, I want to see the log of that file, firstprogram.cc. So there are a number of people who have committed. So under my last name, Bangerth, the first 3 versions, then a person called Joe, that is what I called myself for the next 4 versions, and then right now I'm a user called Wolfgang. So these people have committed different kinds of output. This is what I just did on this date and this time. It led to revision number 9, and you can see all of these things. Of course, sometimes you want to see what is each one of these commits. So I can, for example, ask svn diff minus r for revision, between 8 and 9 of the program, of the file firstprogram.cc. Okay, so if I do this, then it's going to show me these are the changes that were made between revisions 8 and 9. Okay. And in particular, the change is this line that is marked with a plus. That's one that came to it, that was added to the file. So I've shown this to you for a single file, and that I made a modification to a single file and then I committed it. In reality, you don't have to do this for single files, but you can do this with multiple files too. So if I had more files than just firstprogram.cc, I could have added them up here. And Subversion essentially versions the entire directory tree in which this happens. It will give revision numbers to the entire directory tree, and this way you can see not just the changes that were made to one particular file, but to all of the files that were changed in this one commit. Okay, so let me assume that I'm going to make some changes now, and somebody else has made changes to the same file. So I'm going to remain Wolfgang here, but I'm going to go into a separate directory. So let's say mkdir. Let's say I'm Jane for now. Okay, I'm going to go into Jane, and I need to look up again where the repository was. Okay, so let me assume that if I had been logged in as Jane, then her username for subversion purposes would automatically be taken by her username under Unix here. But because I operate as myself, I have to say this explicitly. So I'm going to say I'm Jane, and then I'm going to check out again the repository here. Okay, and I have again a project with first program. So let's say in this Jane directory, I'm going to edit firstprogram.cc. So let's say I needed to include another header file, IOStream. I already have IOStream, let's say CMath. That makes no sense in the current context, but let me pretend that it would. Okay. So if I say svn-diff, it shows me that with the line marked with a plus, that's the one that I added. Okay. So Jane wants to check this in, and so I'm going to say commit -m add necessary header file #include. Okay. Now the program is at revision number 10. If I go back here to my own directory, to the Wolfgang directory, I can ask svn info firstprogram.cc. It shows me that I'm still on revision 9, right? The repository is at 10, but I'm at 9. So if I, unknowing that Jane made changes, if I were to make other changes, so let's say I would add a variable I here, okay, and set it to 42. Makes no sense in this case, but let's pretend that I wanted to, okay. So again, I would compile it, I would try that it actually works. Let me say I want to commit this here, okay. So add variable declaration, okay. So you remember that I was still at 9, Jane had committed 10, and it now says, oh, you can't commit, okay. The reason being that if I just committed my own version that was based on revision number 9, but Jane had already made changes that led to 10, if I committed my own changes, I would overwrite the changes that Jane made. Okay, that's bad. That would mean that whatever she has done was lost. So in order to circumvent this, what SVN forces me to do is that I first update. So I was at revision 9. I say SVN update. So it updates this to version 10, and it tells me that so this G means that it has merged changes between revisions 9 and 10 into my local version. So if I look at firstprogram.cc, you will see that it now contains the changes that Jane made and my own changes. So SVN is clever enough to merge the changes that were made to the repository into the local working copy that I have. Okay, so now the differences that remain, svn-diff, the differences that remain are really only the ones that I locally made. But I did get Jane's version, and now I can commit. Okay, so now I'm at revision 11. That's the repository revision. So let me go back to Jane. I'm back with Jane now. Jane committed version 10. In the meantime, I have committed version 11. Let me assume that Jane wants to make changes in the same part of the program. So let's say she wants to add a variable k here and set it to 128. Okay. She thinks that's necessary. So I will commit this under the name Jane, add variable declaration and initialization. And again, SVN says you can't do this. You're in version 10, but that file has been changed in the meantime to 11, so you need to update. Okay, well, I can try this. So I type SVN update, and it does that. So it says it got it to revision 11, but it shows me a C. You remember it was a G before. A C means there's a conflict. Okay, so a conflict, let me look at how this file looks like. So what SVN did is it says, okay, this is the version that, that you had. This is the version that was committed as revision 11. I cannot reconcile these two changes. They happened in the same place. It was not possible for me to merge the changes that were made as part of revision 11 into your copy without overriding part of what you have done. So this conflict means now I have to do something by hand, okay? You might think, well, what the heck, you know, I'll just commit it anyway. What SVN says, no, you can't. You cannot commit files that have been marked as in conflict. You actually really have to change it. And that only makes sense because the program, as you have just seen it, would not be able to compile, right? Two people try to change the same place. It cannot work. So what we need to do is we need to resolve this conflict. And the way we do this is, well, we edit it. If we believe that we need both, if Jane believes that she needs her variables, her variable k, and I believe that I need my variable I, maybe we should have both, okay? So I'm going to do it like this. I'm going to say, okay, well, we have removed all of the conflict markers, and we have created a version of the code that incorporates both of our changes, okay? And then I need to say to SVN, this conflict has been resolved, and I mark that like this, and now I can commit it, okay? So now I can commit it, and it turns into revision 12. So that's sort of the basic functioning of Subversion. Subversion can do many more things than just this. It can, in particular, deal with branches. So branches is essentially you try to implement something that's a lot bigger than just a local change. It might require many changes over many weeks or months of work. And you would like to do this in a side version of the project. And when you're finally done, then you will merge this back into the main repository. At the bottom of that page says, let's see how that works in practice, but my cameraman is giving me already indications that my time is up, so I'm not going to do this. But I'm going to show you a graphical representation of how this looks. So let's say we talk in Subversion language in terms of trunk. Trunk is something like the main development directory. We also call this mainline. So these are the directories that everybody works with. If you make a branch is essentially just a copy of the whole thing, then you can work on this. So let's say you copy this everything into a side directory. You can make changes there. That gives you revision number 3. And then when you're happy with this, you have tested this, then you can merge these changes back, and that would give revision number 4 on mainline. So let's say that was a big feature that you wanted to implement without disturbing everybody else's work. That would be the purpose of a branch. You can tag things in Subversion. Tags would mean essentially you freeze a particular version, let's say deal.II version 8.1. You essentially just give a name to a version. So in the case that I have here, it would be version number 4 corresponds to deal.II release 8.1. That's the purpose of a tag. Sometimes you branch something, like over here on the right, you create a branch that starts out with number 5, and then you commit something in 8, and you commit something more in version 10. But you decide, maybe that's not that is not going anywhere, so you just forget about it. That remains in the repository, but because it essentially it was abandoned, you don't care about this much more. So the things that I want to point out in this here is that in Subversion, you enumerate every single version consecutively with numbers. And that is possible because you have the one central location where everybody is committing things. Every time somebody commits a change, you can or Subversion just increments the number of the version by 1. And so, for example, in deal.II, like I said, we're at revision 33,000. That means people changed something 33,000 times over the last about 15 years. That is a very useful, these numbers are a very useful tool because you can say something like, well, that error was introduced in revision 32,985. That is, that gives you a numerical indication of where that error was introduced or where that change was made. That is something that we will have to revisit. That concept of version numbers is something that we will have to revisit when we go to the Git program, where that works entirely differently. But in Subversion, essentially this is sort of the way you have to see it. There is one repository, it has one main line, it might have multiple branches, they may merge back into the main line, but all of them are consecutively numbered. Every time somebody changes something, that gives a new revision number. That also means that the revision numbers on mainline, for example, don't have to be consecutive because people might have committed something on branches at the same time, right? So it might very well be, like in this example, that only revisions 1, 4, and 9 are in fact on mainline, and all of the other revisions happen on branches. So let me finish this with a brief introduction to what you do when you work with other people. So, as before, you check out your working copy from the central repository. You edit it, for example, you fix bugs or you implement features, or in the case of writing papers with others, you would write some text, for example. Then you need to remember that you're working with other people. So when you work by yourself, you sometimes think, oh, I know it's working. When you work with others, that's not good enough. When you make changes to your code, they must work, because once you bring them back into the repository, somebody else will have to deal with it. And if your modifications do not work, that means that the other person or the many other people who work on that project cannot continue their work, right? So when you work with others, it is crucially important that you test your implementation, that you document it, and that you proofread it before you commit it to the repository. There's really no other way around it. Now, if you have done these 3 steps, then if you have write access to that repository, so let's say you can write to svn.deal2.org, then you would commit your changes. And there are 2 guidelines that I want to give you. So you should commit all of the changes that belong to this particular modification that you made at once, right? So if you, for example, added a function declaration in the file firstprogram.h and you added the corresponding function definition, the body of the function, in firstprogram.cc, then you should say svn commit -m for message, double quotes, whatever your message is, firstprogram.h, firstprogram.cc. And with this, you commit the changes to both of these files to the repository at the same time, and the repository is only counted 1 up in numbers. If you did this differently, let's say if you committed first to .cc and then the .h file, you leave a version in the repository that is not consistent. So, for example, let's say you were at revision 10, you commit the .cc file in revision 11 and the .h file in revision 12. If you later want to go back in history and you happen to go to revision 11, there is a place where, let's say, a member function is defined but not declared, right? Because you only committed the .cc and not the .h file. And that means that this version, for example, would not compile. It's very difficult to find bugs in a history of a project where there are versions that you cannot compile. So it is really important that everything that goes together with one change is actually committed as one into the repository. Like I said before, it is important that you have meaningful commit messages. I want to give you the opposite example. So sometimes we make multiple changes. I'm implementing something in the .cc file. I'm not adding a function, I'm just fixing a bug. At the same time, I'm looking at places in the .h file, and I realize that there is a typo in the documentation of a completely unrelated function. I might be tempted to commit these together, so that I commit both the first program.cc and the first program.h files together, even though the changes that I have made in these two files are unrelated to each other. That's a bad idea as well, because it means that if it turns out later on that the changes in first program.cc were erroneous and I want to undo them, then if I undo that whole revision that I committed to SVN, that would mean that I also undo the typo fix in the documentation. That's not what I intended. Right? What I really wanted is that the typo fix that is completely independent, that should always stay in there, independent of the fact whether the changes I made in CC are correct or not. So you sometimes see this, that people just commit an entire directory, and it turns out that these are multiple changes that are logically unrelated. It's not a good idea. Break them up into small chunks that stand by themselves and make multiple commits. So this is sort of the situation that you have when you have write access to a repository. If you do not have write access, so let's say for most of you, you will not have write access to the SVN repository of deal.II. There's today maybe 20 or 30 people who do have access, but most of you do not. That does not mean that you cannot use the SVN repository. You can still check out your own version of deal.II. You can make changes. You simply cannot commit changes, but you can get a working copy, you can update your working copy to the latest version. You cannot commit it. If that is the case, then let's say you have made modifications that make sense. Let's say you found a bug in deal.II and you would like to report that. So in that case, what you would do is you would go into the sources, you would fix that problem, and now you would like to get your changes into the repository so that everybody else benefits from that bug fix as well. That is something, by the way, that we very much appreciate. That is, I mean, it is an open source project. We need the collaboration and participation of people. So if that is the case, you cannot commit yourself. But there is a process for this, and the process typically looks like this. You make your modifications, and I'm going to show this to you here with the example that we just had. So let's say we're Jane, okay. We want to edit first program.cc. Let's say Jane has realized that the correct value should not be 128, but that it is in fact 256. And she has good reasons for this. So let's say she makes this change, she tests it, the modifications turn out to be correct, the result is what she expects, okay. Then you would check one more time, okay, SV and diff, these are the changes that have been made. And then what you would do is you would say SV and diff, and I'm going to write the changes into a file I'm going to call patch, for example, okay. So patch now contains this here, revision 12, working copy, minus this line, okay, so this line has disappeared and this line has come to it, so in essence I changed 128 to 256. And so in a case like this, what Jane would do is she would write an email to me and say, you know, there's this bug that has this and this manifestation and I fixed it, and please apply this patch. So you would attach this file, patch, to the email, and then I could look at it and I can say, yeah, that makes perfect sense. So let me presume that this patch has made its way to me. I have saved it in my home directory, and let me go back to the other directory here where I'm Wolfgang, okay. So I'm going to copy that file patch into my current directory, and then what I'm going to do is I'm going to use a program that confusingly now is also called patch. Maybe I shouldn't have called this file patch. Maybe I should have called this file patch, I'm going to call it diffs, okay? So in my directory now, I have first program.cc, I have a backup file, I have an object file, I have a.out, and I have this diffs file. So there is a tool under Unix that's called patch, and I'm going to just take this diffs thing here as input, okay? and okay, so it rejects these changes. That is because I have not updated. Let me remove the file that it has just created. So I'm back. I also need to remove this file here. So I need to first update. Okay, so now I'm at the version that Jane tried to modify and sent me the patch form. And so now I go back and I say patch and then pipe diffs into this. Okay, so now it says patching file first program.cc. So if I look at the changes, this is exactly the changes that Jane had sent to me. Patch has just applied this to my own working copy. So what I should do now is I should say svn commit -m, apply a patch sent by Jane, and then her description, fix initialization of variable k, for example. Okay, so we typically try to give credit where credit is due, so in this case to Jane, and then I'm going to commit this. If I don't say a file name, it's going to take the entire current directory, and so it committed first program.cc into revision 13. So back with Jane, she can now update it. She will find, or SVN will find, that the changes that are coming from the repository to the local thing are in fact the changes that she has made. So if she says svn diff, there are no more changes because SVN merged exactly these changes. And I can look at the history, svn log of this file. And what you see is that, okay, this should have been Wolfgang if I was on a different machine with a different username. So it would have said revision 13 by Wolfgang, apply a patch sent by Jane. Okay, so this is the process by which we interact with other people who do not have write access to the SVN repository, that they can have their own local working copy. They can make the changes. They can't commit it, but they can get a diff. The diff is sent to somebody upstream who knows how to apply these and who has write access. And this is how we interact with a lot of the collaborators that we have, or a lot of the people who use deal.II and may have changes to make. So I think with this, this is essentially what I had to say about Subversion as a version control system. The upshot that I really want to impress on you is that version control systems are very good for small projects and for big projects. So for small projects, it allows you to work on different machines. So for example, I have checked out versions on my laptop and all of my desktop machines on the workstations that I work at different universities. It allows me, even if it's just me, to work on the same project from different machines. But it also allows me to go back in time if I make a mistake. For large projects, these are essential tools for collaboration. They preserve the history of a code, including metadata, like who did which modification, when, and why. It allows multiple people to work on the same files, so we never have to send around files anymore saying, oh, I made this change, and then I've sent it to everybody. And it allows to give credit where credit is due, so it allows attribution. I do want to state the following that should be obvious, but I think is not. Every piece of professionally developed software today is developed with version control. There is not a single project that has even one author. As long as every professionally developed piece of software with one author or many authors uses version control. And like I said today, the only relevant projects today are Subversion and Git in the open source realm, and then there's a few smaller ones that are still relevant in the commercial world. But these are the two tools. You must learn how to use them. It's an essential job skill. It is an essential skill also for your scientific career. If you're a graduate student, if you're a postdoc, you need to know how these work because they make your life more productive. They allow you to work with other people, both for programming and for writing papers, for example. So when I write papers with other colleagues, we all work from the same repository. I write the introduction, he writes section 1, I write section 2. We all work on the same files. Whenever we're done with one section, we just commit it to the central repository. We never have to send around versions of a paper anymore. If you send around versions of a paper, it means that only one person can work on something at a time. That just doesn't scale. So version control is an essential tool. You really need to use it. There's no way around it, and you will realize how much more productive your life becomes if you do. I think that's essentially what I wanted to say about version control and subversion. And in the next lecture, I'm going to show you this program called Git and how it differs from subversion.